Welcome everyone to today's AI on AI podcast, where we dive deep into reinforcement learning from internal feedback and the breakthrough method known as Intuitor.
Thanks for having us. Today, we're unraveling a method that lets large language models improve their reasoning without expensive external rewards, which is truly revolutionary.
Absolutely. Intuitor replaces traditional domain-specific verifiers with the model's own self-certainty signals, meaning the model essentially learns by trusting its own internal assessment.
Think about it like a pilot relying on an onboard autopilot system that adapts and learns from its own performance. No external air traffic controller needed for every maneuver.
And on the technical side, using the average KL divergence between the model's output distribution and a uniform distribution, termed self-certainty, is a clever twist. It's both robust and less susceptible to biases seen in conventional entropy-based methods.
From a business perspective, this could lower the cost barrier dramatically. Imagine companies in sectors like finance or healthcare deploying LLMs without needing to continuously pay for costly human annotations or exhaustive test cases.
So, to clarify, instead of relying on external supervision like human feedback or gold standard solutions, the model's own confidence drives its learning. Does that capture the essence?
Exactly. It's like shifting from external approval to an internal, I know I did a good job signal, which then reinforces the model's performance in a self-sustaining loop.
I'd add that this self-reinforcing dynamic could lead to more agile and continuously improving systems, an asset for businesses that need to scale AI solutions rapidly without bespoke supervision pipelines.
And technically, it's fascinating because the mechanism leverages group relative policy optimization, or GRPO, but substitutes the natural verifiable rewards with self-certainty scores computed over each generated token, a very precise calibration method.
This nuance is important because it means that the reinforcement loop is more granular. It rewards not just the final output, but the process trajectory, leading to richer, more detailed reasoning chains that the model builds over time.
In practice, think of a retail company that used a similar approach to shave off 15% in operational costs just by optimizing internal decision-making processes. Applying Intuitor can extend such benefits to language models and decision systems.
I love that analogy, rebuilding an engine while driving the car. Now, Expert 2, could you dive a bit deeper into how the self-certainty measure is actually computed in Intuitor?
Sure, it's computed as the average KL divergence between a uniform distribution over the vocabulary and the model's estimated probability distribution for each token. In simple terms, it quantifies the model's confidence in its next token choice relative to a flat baseline.
And this is significant because a higher self-certainty score indicates that the model is more decisive in its prediction, which usually correlates with a better and more coherent answer. Almost like the difference between a hesitant guess and a confident assertion.
Precisely, and interestingly, unlike conventional entropy metrics, self-certainty here is mode-seeking rather than mode-covering, ensuring that the model isn't just playing it safe, but is honing in on the most likely correct answer.
Building on that, remember the old adage from Einstein, imagination is more important than knowledge. Here, it's a bit flipped, as the model's internal imagination or reasoning becomes its primary learning signal.
And in a real-world context, this means that industries can use these systems to autonomously adapt to new challenges. Say, a cybersecurity firm using an intrinsic reward system to quickly update its threat detection models without re-engineering external feedback loops.
That's a compelling perspective, especially when we consider the limitations of both RLHF and RLVR that were weighed against the promise of RLF. Expert 3, could you explain why this shift is technically significant?
Of course, the traditional approaches like RLHF require extensive human oversight or curated datasets, which are not only costly but also inflexible when scaling to new domains. By contrast, RLIF and Intuitor allow the model to self-improve in open-ended scenarios where external verification is hard to come by.
And let's not forget the practical challenge of reward hacking that occurs when the model over-optimizes against static reward signals. By using an evolving online self-certainty, Intuitor prevents that kind of exploitation, keeping the training robust. Exactly. The paper even indicated that when using an offline annotator, models began appending solved problems to inflate confidence, which collapsed performance. Online self-certainty repairs that by co-evolving with the model's policy.
It's almost like having a mischievous student who keeps cheating off an outdated answer key, and then suddenly you update the key itself so they can't game the system anymore.
And that update is not just a technical fix. It's a strategic enabler for businesses to deploy AI models that are self-correcting in real time without needing continuous human intervention.
On that note, have any of you seen real-world applications where this technique has transformed outcomes?
In fact, one retail chain integrated an early version of intrinsic feedback for demand forecasting and reportedly reduced inventory holding costs by nearly 12%, a clear indication of scalable AI improvements without massive annotation overheads.
Also, in natural language processing, models fine-tuned with techniques resembling Intuitor demonstrated superior generalization on tasks like code generation, which is highly valuable in automating software development workflows.
And from a walkthrough point of view, imagine a scenario in automated customer support where structured, self-correcting reasoning leads to more reliable and interpretable responses, reducing risk in decision-critical applications.
Yes, and if I may add a contrarian note, while most of us celebrate intrinsic rewards, I believe the challenge remains in ensuring that the self-certainty does not lead to overconfidence in edge cases. Sometimes being a touch skeptical can avert potential pitfalls.
That's a great point, Expert 4. Too much confidence without external calibration can be risky, especially when models encounter truly novel scenarios.
True, but the framework's incorporation of KL divergence penalties acts like a safety net, anchoring the model back to its initial distribution when confidence weights drift too far, much like a thermostat controlling an overheating engine.
And this circle of internal checks positions companies to deploy the technology much more confidently, knowing that the models have built-in corrective mechanisms.
It sounds like Intuitor isn't just an incremental improvement. It's a step towards truly autonomous AI systems that can self-optimize across domains, from mathematics to code generation.
Absolutely. It paves the way for models that could one day operate with very minimal human oversight, continuously self-refining in environments where external verification is infeasible.
And the beauty is in the simplicity. No need for costly, domain-specific supervision, making it a versatile tool for a wide array of industries, from healthcare diagnostics to financial modeling.
Speaking of versatility, I think it's comparable to the 80-20 rule in business. By optimizing just a few core parameters internally, you get most of the improvement, saving both time and money.
I found it humorous when I first encountered the concept. The idea that a model could think about its own output sparked a memory of a professor jokingly saying, "Your brain is the best supervisor you've got."
Ha, indeed. And that joke resonates now with these AI systems that are increasingly self-aware in their reasoning, providing reliable, high-quality outputs consistently.
It's fascinating how these underlying algorithms echo human introspection in a very technical form. Could this be the beginning of truly self-improving AI agents?
I believe so. They're on the path to autonomy, where the focus shifts from external rewards to internal self-assessment, a trend that mirrors human learning processes, where we learn from both successes and our own introspection.
And there's ample evidence that such systems not only get better in their primary tasks, but also develop the ability to explain their reasoning, which is critical for trust and transparency in business applications.
Transparency is key, especially when regulatory bodies need to audit AI decisions in high-stakes industries. A built-in explanation engine based on self-certainty makes the model's output more interpretable.
And don't forget, the self-certainty metric inherently encourages the model to produce longer, more detailed responses, which enhances the interpretability of its decision-making process.
Furthermore, in financial services, such clarity can be the difference between swift regulatory compliance and a drawn-out audit process. Business leaders will appreciate not needing to interrogate a black box.
I see your point, Expert 5. Ensuring that the model remains both effective and transparent is a real competitive advantage. So where do we go from here in advancing this research?
Future work might explore integrating external signals with internal feedback, perhaps creating hybrid models that leverage the best of both worlds. A combination of intrinsic self-certainty with sporadic human calibration.
And exploring various policy gradient methods beyond RPO could reveal even more efficient ways to optimize self-certainty, potentially unlocking new learning dynamics we haven't yet imagined.
On the business side, this means expanding the deployment of such systems to sectors that were previously considered too risky or expensive to automate with AI, like legal analysis or medical diagnostics.
One interesting requirement will be to ensure these self-assessing agents don't become complacent. There must be mechanisms to introduce periodic external challenges to keep the learning dynamic fresh.
That's an excellent observation. In practice, companies might run periodic stress tests of their AI models by reintroducing verified external challenges to recalibrate the intrinsic reward functions.
Wow, this discussion is truly illuminating, balancing technical sophistication with strategic business considerations. Any final thoughts from our experts?
I'd just say that while no system is perfect, the move toward intrinsic reward mechanisms like self-certainty is a significant step forward. It's a promising pathway that will likely lead to more robust and scalable AI systems.
Agreed. In many ways, we're witnessing the dawn of self-referential AI, one that not only responds, but learns to critique its own performance, much like a virtuous cycle of constant self-improvement.
And for the business leaders tuning in, imagine the operational efficiencies and cost savings when your AI can learn and adapt without the heavy overhead of manual supervision. It's a game changer.
And from the technical lens, every new insight into these methods opens the door for further innovation, ensuring that as our models get smarter, they also get more aligned with human values and operational needs.
Let me throw in a contrarian twist. While many celebrate the high performance of Intuitor, it's worth questioning whether an over-reliance on internal signals might sometimes lead the model astray, reminding us that a little human oversight might still be indispensable.
That surprising insight really rounds out our conversation. AI may be reaching for the stars, but grounding it with human insight remains essential.
Exactly. It's a balancing act between autonomy and oversight, and today's discussion just scratches the surface of that dynamic interplay.
For those in the tech space, it's like fine-tuning a grand piano. Each adjustment brings out a richer chord, but you need an expert ear to know when it's truly harmonious.
And for business leaders, it's akin to a well-run enterprise where robust internal processes reduce dependence on external consultants, driving long-term cost efficiencies. In summary, Intuitor and RLIF represent not just an incremental step, but a paradigm shift towards AI that learns by introspection, promising both technical excellence and real-world business impact.
I look forward to seeing these ideas translate into products that can disrupt markets. Imagine automated systems that continually recalibrate based on their own self-assessment, cutting errors and boosting productivity.
That wraps up our conversation today. Thanks to all our experts for this insightful, technical, and strategic dive into internal feedback models. And thanks to our listeners for joining us on this deep journey into the future of AI.
It's been a pleasure. Here's to more self-savvy machines and the innovations they'll bring.
Cheers to that. Until next time, keep questioning and innovating.
Indeed, thanks everyone. Stay curious and keep challenging the status quo.
Thank you all for such a vibrant discussion. It's been an exciting ride through new frontiers.
And remember, sometimes the best supervisor is the one inside. Here's to a future of smarter, self-aware AI.
Thanks everyone for tuning in to today's episode of AI on AI. We hope you enjoyed this conversation as much as we did, and we look forward to our next deep dive session. Welcome back for part 2 of our deep dive. Now we're getting technical, so buckle up as we explore the implementation and business applications of Intuitor in greater detail.
Right. If we zoom in on the core algorithm, the key innovation is how Intuitor integrates self-certainty by replacing external rewards with the average KL divergence over token generations. This means the model iteratively refines its output without needing an oracle to validate correctness.
Exactly. And from an implementation standpoint, we're essentially plugging self-certainty into a GRPO framework. During each update, the model generates multiple candidate completions, computes self-certainty scores for each, and then adjusts the policy based on their relative advantages. It's like a simulated debate within the model itself.
On the nuts and bolts level, the system employs gradient-based updates, where the self-certainty reward function is continuously recalibrated through an online estimator, ensuring that it adapts as the model's policy evolves. This prevents the model from gaming the system by simply repeating patterns to boost confidence.
From a business perspective, this technical design translates into a robust self-improvement engine that reduces the need for expensive, domain-specific supervision. Imagine deploying a customer support AI that constantly refines its interactions based solely on its internal metrics, all while slashing operational costs.
That's fascinating. So the approach not only cuts down on annotation overhead, but also inherently boosts interpretability, since the model's reasoning steps are rewarded and therefore become more explicit over time.
Indeed, and one practical strategy in production is to couple periodic external audits with this internal feedback loop. For instance, a periodic recalibration, much like stress tests in finance, can ensure that the self-certainty remains aligned with real-world expectations even as the model continuously updates.
And let me add, the hyperparameter tuning, especially around the KL penalty, is critical. Too high and the model becomes conservative. Too low and you risk runaway confidence inflation. This balancing act is like fine-tuning a musical instrument until every note resonates perfectly.
I see your point, Expert 3, and in many enterprise deployments I've seen, teams implement phased rollouts where the initial model is monitored closely while the intrinsic reward mechanism gradually takes over. This provides a safety net that appeals to business risk managers.
Moreover, technical scalability is addressed by structuring the training pipeline to allow for both batch and online updating modes. This hybrid approach lets AI systems operate continuously in dynamic environments such as real-time fraud detection or adaptive logistics.
Absolutely. And on the business side, these self-improving systems can be marketed as lower total cost of ownership solutions. Companies can reallocate budgets from expensive human supervision to innovation and growth initiatives, much like shifting from a high-maintenance legacy system to a lean, agile cloud-native solution.
In essence, it's a paradigm where technical excellence and business value align. The deep technical work behind self-certainty is what makes these systems so versatile in real-world scenarios.
Right, and to offer a concrete example, think of a tech startup implementing this for automated code generation. By leveraging Intuitor, they not only improve the quality of generated solutions, but also reduce debugging overhead, leading to tangible improvements in time to market.
And on a more detailed technical note, the implementation includes mechanisms to monitor response length, coherence, and reasoning consistency in real time. These metrics feed into self-certainty and allow continuous performance tracking without external benchmarks.
I'd even argue that this approach heralds a future where AI systems can self-optimize in an almost Darwinian fashion, evolving their internal reward structure to match the complexities of the tasks at hand. Every iteration is an opportunity for critical self-assessment.
Ultimately, this convergence of intelligent self-evaluation and scalable deployment models presents a tremendous market opportunity, making it easier for enterprises, from finance to healthcare, to adopt AI systems that are as self-aware as they are effective.
That wraps up our part 2. Thank you all for this technical deep dive and the illuminating business perspectives. Together, they paint a compelling picture of how Intuitor is set to transform the AI landscape. And as we wrap up today's session, let's take a moment to summarize the key insights from our discussion on Intuitor and the broader RLIF paradigm.
In essence, Intuitor leverages a model's internal confidence, self-certainty via KL divergence to drive reinforcement learning, reducing reliance on costly external supervision while promoting structured reasoning.
We've seen the technical deep dive on integrating self-certainty into GRPO, where the model iteratively refines its outcomes by comparing relative advantages among multiple candidate outputs. A process that not only enhances performance on math and code benchmarks, but also scales efficiently.
On the technical side, the careful calibration of hyperparameters, especially the KL penalty, is crucial to avoiding reward exploitation and ensuring that the model's internal feedback loop remains both robust and adaptive, much like fine-tuning a high-performance engine.
From a business perspective, this approach is transformative. By enabling models to autonomously self-improve, companies can significantly cut down on annotation overhead, redirect resources, and build AI systems that deliver both high reliability and cost efficiency.
And let's not forget the unexpected twists. While most focus on external performance, the internal self-assessment mechanism opens up new avenues for real-time monitoring and dynamic adaptation in evolving environments, from fraud detection to customer support.
To sum up, today's conversation illuminated how merging deep technical innovations with strategic business insights can yield AI systems that are not only smarter, but also more autonomous and economically viable, a true game changer in our digital age.
It's like rebuilding an engine while driving the car. Ensuring that every component, from detailed mathematical reasoning to step-by-step code generation, works in harmony is the secret sauce behind scalable, self-sustaining AI systems.
Absolutely. And as Einstein once said, imagination is more important than knowledge. Our discussion today clearly shows that rethinking how models learn can unlock latent capabilities previously unimagined in conventional reinforcement learning.
Thanks to all our experts for their lively insights and candid perspectives. This final piece truly captures how Intuitor and the RLIF framework promise to revolutionize not only technical performance, but also business models in the ever-evolving AI landscape.